Hi, it is week 16. Yay! It is the end of the semester. You have every right to be very happy and excited. It's a lot of work, and it is especially a lot of work to take a class online. So we are in our last week. It is going to be a short week by design. I know that at the end of the semester, things get busy, things get hectic. And so there are only 3 instructional videos to watch. The study guide is shorter, the quiz is shorter, because I know that 1, you're tired, and 2, there's probably a lot of other things going on in other classes. So what we're going to do this week are talk about 3 small topics, but they're important topics, so please don't blow this off. I appreciate it if you would keep going till the end. We are going to talk about pH calculations, buffers, and pH indicators. So let's talk about the pretty one first. pH indicators are chemical compounds that change color when you put them in solutions or compounds of different pH. You may have done the infamous red cabbage juice experiment in elementary school or junior high. It's a classic because it's fun and it's pretty, and I love indicators because they have names like phenolphthalein and bromothiamyl blue and Congo red. They're kind of exotic and they're beautiful and they're really fun to work with. So we're going to talk about how they work. They don't all change color right at 7 between acids and bases. Some change color at pH 5, some change color at pH 10. They all depend on the specific compound that's being used as an indicator. We're going to talk about how do you calculate pH from hydronium ion concentration on your calculator. And I will walk you through the button punching. It's not hard, but last week we were doing it the quick and dirty way, just looking at the hydronium ion concentration, pulling that power off of the number 10, and that was our pH. That works if the numbers are nice, but you know better. You know, numbers and life is never that nice. Sometimes it's complicated. It's easy to do. I'll walk you through the button punching. You have a fancy scientific calculator, so it won't be hard, and we're only going to do one type of calculations. And then lastly, we're going to talk about buffers. Now, buffers are things that resist a change in pH. You may have heard of buffered aspirin. Aspirin it has a tendency to be very acidic and can eat the lining out of your stomach because your stomach is acidic. Aspirin is acidic. You add acids to acids, can be really harsh on the stomach. What buffered aspirin does is it resists extreme changes in pH when you take that aspirin. And there are lots of buffers in the human body because in order to keep your blood at the correct pH, it has to have a lot of buffers in there, because if you get outside that narrow range of pH, you can throw your body into a state that is too acidic or too basic, and a patient can actually die. There are multiple biologic systems that require buffers. And so we're going to talk about chemically what actually a buffer does and how does it do it. So that's it. That's going to be the end of our course. Like I said, short study guide, short quiz, and a reminder, the computer program is programmed to throw out your lowest study guide or your lowest quiz all semester. That's been happening since the beginning. Do whatever you need to do to use that to your benefit. If this tends up to being one of your better ones, it'll throw out one of your lower ones. The computer does the math, which is great because you and I don't have to do it. It's been a joy working with you, and best of luck in all of your future endeavors.